Okay, here's our last problem from 14.2, our last example. We want to investigate this limit and determine its value, if it exists, or show that it does not exist. And thinking about the degree of the numerator and the denominator isn't as helpful here. Upstairs I have something that looks kind of cubic, and downstairs I have something kind of quadratic, or something to the fourth power. Which is it? Right? And that suggests that something weird is going on here. Cubic over squared might go to 0, right? But cubic over squared could go to 0, but cubic over the fourth power might not go to 0. And in fact, you check, I'm not going to do this part now, along x equals 0 and y equals 0. And also, you can actually show for any line through the origin of the form y equals mx, all those limits are going to be 0 along every path, right? So we'll have there that xy squared over x squared plus y to the fourth approaches 0 along all lines through the origin. So now what? Well, what you need to do is to look at this quotient and kind of look to see if there's a substitution you can make there that would cause the numerator and the denominator to balance. Right? So if I can make the top and the bottom both fourth degree, right? If I can make them both fourth degree, then terms might cancel and we might be able to show a limit of something other than 0. How could you make these balance, right? I've got xy squared, so if I were to make x equals y squared, we'd have y to the fourth on top, and down here we'd also have y to the fourth. Let's try that. So let's investigate what happens with this limit along the path x equals y squared. So we'll substitute everywhere we see an x, we'll substitute y squared, and then we won't have any x's in our limit. And we'll look at what happens as y goes to 0. So we have substituting x equals y squared, we get y squared, y squared. Downstairs we have x squared squared, so x is y squared squared plus y to the fourth. Little algebra, and we of course get y to the fourth over 2y to the fourth. Can cancel those, and the remaining quotient is 1/2. So the limit as y approaches 0 along this parabola is 1/2. Okay, so along all lines approaching the origin, we get limit 0, but along this parabolic path, we get 1/2. Different limits on different paths. That tells us that the limit does not exist. All right, go do some homework.